Well, welcome to day 21 of extension to a question a day. So verify that I is a solution to that polynomial equaling zero, hence find all the solutions. So to verify that anything's a solution, we need to substitute it in, don't we? So the left-hand side of this is z to the 4 plus 4z cubed plus 3z squared plus 4z plus 2, right? So if you put I in there, you got I to the 4 plus 4I cubed plus 3I squared plus 4I plus 2. Now, I to the 4, and look, I want to just discuss this right now so I don't repeat myself over it, but all right, here's I up here. This is the imaginary part of Z, and this is the real part of Z, and that's 1 unit, 1, 1, minus 1, minus 1. Now, here's I up here. Now, if you multiply by I, right, that's I there. If you multiply by I, what you do is you rotate 90 degrees anti-clockwise, right? So timesing by I means you rotate 90 degrees anti-clockwise. So times that I by I, you're going to rotate it that way by 90 degrees, right? That's 90 degrees in there. So you'll end up down here at I squared. And of course, if you times by I, you rotate 90 degrees and you end up at I cubed. And then here you end up at I to the power of 4. All right, so there's one quick, easy way to work out powers of I by just considering the Argand diagram there. So I to the power of 4 is 1. I to the power of 3 is minus I. I to the power of 2 is minus 1. I is, of course, I. All right, so we can now collect together things that are similar, like we've got 1 and 2 is 3, and we've got minus 3, and we've got minus 4i, and we've got plus 4i, so we've got 0 plus 0 is 0. All right, now that equals to the right-hand side of the original equation, so therefore I is a solution. So we're asked to verify it, we verify it. Now, hence find all the other solutions. So there's a very key point here to acknowledge, right? This polynomial's got real coefficients, yeah? And if a polynomial has real coefficients, then the complex roots occur in conjugate pairs. Now, what do I mean by complex roots? Well, if there's a root on the real axis, then it's not going to get repeated, so it doesn't occur in a pair as such. It's just that's one root. But if there's any root that's not on the real axis, so it has a imaginary part, then I'm calling it a complex root. It'll occur in conjugate pairs. As long as the coefficients are real, and there's a 1, a 4, a 3, a 4, and of course the constant term is 2. So that is satisfied, they are real. So let me just grab some more room. I need to come back up here. So if we know that one root is I, since I is a root, then minus I is also a root. All right. Now we know, therefore, z minus I, because if I is a root, then z minus I is a factor, and z plus I is a factor. Therefore, z minus I, z plus I is a factor. If you think about it, if a number can be divided by 3 and a number can also be divided by 4, then that number can be divided by 12. And a little bit of care needs to be taken with that analogy, in that if the two numbers I chose with the numerical analogy had a common factor, we wouldn't get the same situation. You know, like if 18 is divisible by 6 and 18 is divisible by 9, well, 18 is not divisible by 6 times 9, is it? Right? Because 6 and 9 both have a common factor of 3 in there. So we've got to watch what we do there. But with this situation, z minus I and z plus I don't have a common factor. Right? So the product of them will be a factor. In which case, what does that equal to? Well, a squared minus b squared, because it's a minus, it looks like the old a minus b, a plus b, doesn't it? Right, which is a squared minus b squared. So if we just sort that out, this thing here is a squared minus b squared, which is z squared minus 1, which is z squared plus 1. So z squared plus 1 is a factor. So we can divide that into, so z squared plus 1 can be divided into the original polynomial, which is z to the 4 plus 4z cubed plus 3z squared plus 4z plus 2. Let me just check. Z4, 4, 3. So 4, 3, 4, 2, all pluses. 4, 3, 4, 2, all pluses. Yep. So let's do that division. So to get Z4, which is our first term, what do we multiply the first thing here by, or the highest power by? We multiply by z squared. So that's where the z squared comes from. And then I multiply all of this by z squared. So I get z to the 4 and plus z squared times 1 is z squared. And I'm just going to line them up nicely underneath their corresponding powered terms. Now I subtract the blue minus the green there, and I end up with 4z cubed plus 2z squared plus 4z plus 2. All right, so my next thing I'm going to do is go, how do I get 4z cubed out of z squared? Well, I times it by 4z, don't I? So that'll give me 4z cubed, but I'll also get plus the 4z times the 1 there. So I also get plus 4z. So I subtract and I get 2z, sorry, I'll just pop that in blue again. I get 2z squareds plus 2 coming through when I've done that subtraction. And now finally, I want to get 2z squared. I want to get that out of the z squared. So I plus 2. But of course, that times is the whole of the green brackets, right? So I'll get 2z squared plus 2 times 1, and nothing left. So that z squared plus 4z plus 2 on the top there, that there is a factor. In other words, what I've done is I've said that z squared plus 1 times z squared plus 4z plus 2 is equal to this original polynomial. That's where I've got to now. So I already know that the breakdown of this guy was that it's made up of z plus I and z minus I. But this guy, I still need to see if I can figure out what values of z gives us that in as factors, or what solves that equal to 0. So it won't factorise because b squared minus 4ac is 16 minus 4 is 12, right? Square root of 12 is bodges. So I'm just going to do the quadratic formula. So z is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So it's minus 4 plus or minus root 16 minus 4, 12 over 2. So it's minus 4 plus or minus. Now, 12 is a root 4 times root 3, which is 2 root 3, right? So 2 root 3 over 2. Divide top and bottom by 2. It's minus 2 plus or minus root 3. Now, hold on a minute. I can't do mathematics. 16 minus 8. That should have been an 8 there. Oh dear. Whoop, get rid of that. There we go. It's easy to fix at least, isn't it, with this pen? So I get 16 minus 8, which is 8, right? So 16 minus 8, which is 8. And that's root 4 times root 2, so 2 root 2. So it's minus 2 plus or minus root 2. So in other words, our factors would be z plus I and z minus I and minus z minus minus 2 plus root 2 and z minus minus 2 minus root 2. That's what our factors would be. But the question wanted the roots. So the roots are I, minus 2 plus root 2, and minus 2 minus root 2. Just check I've answered that. I think the question wanted the roots, so I'll just check the original question. Find all the solutions. Yeah, so they're all the solutions to that. Not just I, but minus I. So in other words, the solutions to that equation equals 0 are those.